Hello, grade 11 mindsetters. Welcome to Learn Extra Live. I'm Katleho, and this is Peter. You guys all know him, right?
Absolutely.
Yeah.
How are you, Kat?
I'm great, thanks. How are you?
Good, man. It's Thursday. It's a wonderful day, isn't it?
I love Thursdays. It's almost the weekend, so it's always awesome.
And Thursday's the day where all the children in the Afrikaans school hit each other.
Oh, is it? Why?
Because it's Donderdag. But Thursdays are great days, guys, because it's all about mathematical literacy. And I think you're going to do your intro here, and I'm going to go there.
You can do so.
Let's do that.
So remember that today, guys, is revision for you grade 11s. I know you guys always get excited by revision because it is exam time and you love revising math literacy. I know. Remember that you can ask us any questions that you want to on our Facebook page, facebook.com/LearnExtra, and our Twitter handle @LearnExtra. And today you can also call us. You can actually call in. And the first 5 callers will be getting these books sent to them. So just make sure that you call us with perfect questions, with concise questions. And my number is 086 105 8262. And it's on our Facebook page as well, in case I'm saying it a bit too fast. It's also on our Facebook page. And I'm going to be showing you the Facebook page just now. Yay!
Great, Kat, and I'm absolutely thrilled you are, because every week you talk about this thing,
and
I don't know
what it looks like.
you're talking about. So go for it. Tell us all about this.
So this is how it is. Here's our Facebook page. This is where you get the winter school schedules. It says get all the winter school schedules, as you can see. And this is where you can download the book in case it's not sent to you and you're a caller. You could just say, okay, cool, I'm just going to download the book. And you can keep them on your computer, on your phone, so that when winter school starts, you have them. And all the dates are there as well. And our number, and our Twitter page, and everything is here, guys. Remember that today, if you want to ask us any questions, you'll be asking us on our status, not in the inbox, on the status. And you can comment on each other's stuff right here. And I'll be telling Peter, because he's not very techno savvy. As you can see, he looks confused. So I'll be telling him what the questions are. Remember not to send us inbox messages, because we don't receive them. Thank you for allowing me here. I like being here next to your board.
It's nice here, isn't it?
It is.
It's like in control.
Yeah.
Unless something goes wrong with the board.
And then you call me.
Absolutely. Okay. Well, guys, again, fantastic to have you online. And this is our last show for the term, if I remember correctly.
Yes, it is.
And then from next week, you're all on holiday, and we've got a special lineup for you called our winter school, or our boot camp.
Boot camp, that's what it is.
Absolutely. Tell us about the boot camp for grade 11.
So the grade 11 boot camp will be starting on the 9th. It'll go on until the 12th. So that's the 9th, 10th, 11th, 12th. And if you get the book, the schedule is in there. And if you go to the Mindset website or just download it on Facebook, all the times are there for you. So every subject as well. There are many subjects. So make sure that you have all the books, especially for math literacy, because I know Peter, it's his favorite, So make sure that you have the math literacy book. And we'll also be joining you after the fairly long holiday. I don't like being away for that long. But on the 16th is when we're going to be back with our live shows.
16th
of July.
Yes, it's miles away. Everyone's got such a long
holiday. That's why we have boot camp.
This is why we got boot camp, absolutely. And make use of that boot camp, guys. It can be absolutely great. And I think I might see you on that boot camp here. I think so. I don't know. Awesome. They haven't asked me yet. I don't know. They just give me a call, and here I am. Voila. Guys, that's the preamble. My goodness, what an introduction. I think half the show's gone yet. All right. So, what are we doing today? Because it's our last show, and because we're preparing you for these examinations, what we thought we'd do is we just take a few questions that you could find in an exam. Okay, and so what I've done is I found a few questions, and it was actually a paper that was put together by a friend of mine in Natal. And his name's Andrew. And so, Andrew, if you're out there watching, thanks very much for this paper. Really great stuff and well worth going through. Okay. And in fact, some of these questions I used with my grade 11s last year in their July exam. So, let's have a look at it. First thing, here we go. We're going to start off by looking at a few paper 1 type questions just to get warmed up. Okay? And our paper 1 questions, and I know, are there just to test the basics. Do I understand how to find volume? Do I understand how to read a graph? Do I understand how to find the mean, median, or mode? Do I understand how to look at basic probability? Do I understand how to do basic calculations with interest? Do I understand how to look at a financial document and pick up important information? And then the paper 2, we now take all this knowledge that you should have, and we now make sure you can apply it, or see if you can apply it, and hopefully you can. Right, so a few basic paper 1 questions. Let's have a look at the first one. Find the volume of the cylinder below using the formula V is equal to pi times r squared times h. Round your answer to 2 decimal places. Okay, now what we need to do is find the volume, and remember we're actually given a formula. Here it is. Volume equals pi times r squared times h. Very basic, very straightforward, because they've given us the formula. And remember, grade 11s. And you will hear me say this for the whole of this year. And next year when you tune in, you're going to hear me say, that's if they keep me here next year.
Yeah.
You will hear me next year as well say the same thing. If you're given a formula, chances are you have to use that formula. If you don't, you've made a bit of a blunder with it. So let's go for this. So volume is equal to pi times RH. Now normally in matric what's expected is we tell you that pi is going to be 3,14. My radius is, I don't know my radius, but what I do know is I know my diameter. And my diameter is 6 centimeters. Now we know, well, by now we should know anyway, that the radius is half the diameter. Okay, so if I were to look at my arms, right, and look at the tip of this finger to that finger, can you see it? Let me do this, from this finger to that finger, okay, that would be my diameter. My radius is half of it. So from the center of my face to the end of my finger, that would be the radius. Diameter and radius. So my radius is half my diameter. In other words, my radius is going to be 3 centimeters. But I'm going to square it. Why am I going to square it? Because my formula tells me to square it. And so many times in matric, in the end of the year paper, we get guys that say, oh, this is so basic, it's easy, great. Pi times r squared times h. And folk, so many students forget to square the radius. Okay, silly little errors. What a horrible way to lose marks when you know what you're doing, but you make a stupid mistake. Times the height, how high is my, oops, my goodness, what did I do there? Times the height, and our cylinder is 21 centimeters. Now, all we're going to do is we're going to take out our wonderful calculator, and our calculator is going to do the work for us, okay? Don't put yourself under pressure and try and do it all in your head, okay? I never do that because what's in my head is quite scary. So I would rather use my calculator, and I would suggest you do the same. So, on our calculator, we've got 3.14 multiplied by 3 squared. Not just the 3, but 3 squared. Multiplied now by 21. And my answer is going to be a whacking 593,46. Let's see if we remember this. 593.46. Okay, cool. Here we go. 593,46. And what's our unit? It's going to be centimeters squared. Not squared, but rather cubed. Why cubed, folk? Because we're dealing in volume. Now remember, when I'm asked to calculate perimeter, my units are just units. When I'm asked to calculate area, my units are going to be units squared. And when I'm asked to do volume, it's units cubed. Okay. Silly little basics, but vital and crucial if you don't want to lose a mark in your paper. Right, that was our first question. We're happy with it. Everyone is pleased. Now let's move on to the next one. Our next question is this. Nina is traveling, let's try to get it. Nina is traveling at 65 kilometers per hour. How far will she travel in 1 hour and 30 minutes? Okay. So in 1 hour, because she's traveling 65 kilometers per hour, it's basically saying in 1 hour, you're going to travel 65 kilometers. If I'm in my car and I'm traveling at a speed of 120 kilometers an hour, on a 60 zone, it means I'm speeding. Eh?
Yeah.
But if I'm traveling at 120 kilometers an hour, what does that speed mean? It means that after traveling for an hour, I've covered 120 kilometers. So listen to it carefully. 120 kilometers per hour. So if I travel for 2 hours, I'm traveling I would have traveled 240 kilometers. 120 in the first hour, 120 in the second hour. Now, here we've got 65 kilometers an hour. In other words, folks, in my first hour, if I get in my car and I get on the highway and I put my foot down, okay, and I've got a very old car and I manage to travel 65 kilometers an hour and watch all the other cars come zooming past me, but there I am going 65 kilometers an hour. After traveling an hour, I would have only gone 65 kilometers away from where I started. After 2 hours, I've gone twice as far. So I've gone 2 times 65 kilometers. Now, after 1.5 hours, how far have I gone? Well, I've got 65 kilometers in 1 hour. So in 1 hour and 30 minutes, and that 30 minutes means half an hour, I would have covered 1.5 hours. All right? So my distance is 1.5 times that 65. So let's do that on our calculator. We're going to say, okay, so if I do 65, I'm going to multiply it by 1.5, and my answer now is going to be 97.5 kilometers. So I've now done 97.5 kilometers. Happy? Of course you are. It's basic, eh? It's simple stuff. There's another question we're going to do later on when things get a little more complicated, but we'll worry about that just now. Okay, next one. 30 children were asked to describe the color of their eyes. The results are shown in the pictogram below. Wait, what's a pictogram? I'll show you what a pictogram is. There's a pictogram. Okay, so if we look at this pictogram, what we're actually showing here is every time you see a funny little man drawn, and that looks like my kind of drawing. I mean, that's the closest I'll get to drawing a man, okay? So every time you see a whole little man drawn, what does it mean? It means one whole man represents 2 people. Half a man represents 1 person. Oy, and that threw a bit of confusion with the guys that wrote this exam for me last year. Because they said, hold on, a whole man represents 1. But you know, if the key tells you that a whole man represents 2 people, it represents 2. I could have said a whole man represents 10 people, and half a man represents 5 people. Okay? So on my diagram, a whole man represents 2 people, half a man represents 1 person. So let's have a look at this. How many people then have blue eyes? Well, there's 1 man times 2 means 2 people. How many people have gray eyes? Let's have a look at this. That's going to be 2, 4, 6, 8, 10, 12 people have gray eyes. How many people have brown? 2, 4, 6, 8, 9 people. How many people have green? Uh-oh, we don't know. But I bet one of the questions are going to be, how many people have green eyes? So watch out for this question. Then, how many people have other color eyes? Well, 4 people. What other color eyes can you get if your eyes aren't blue, gray, or brown?
Perhaps both, or a mixture.
A mixture with like one eye green and one eye blue. Like
mine are more black than brown.
Okay.
Yeah, scary people, like cat eyes.
Cat eyes, all right. All right, Kat, let's move on then. So now what we're actually doing is we're going to read the question. And the first question is, how many people have brown eyes? Let's have a look at that. And we've done it, hey? We've said 9 people have brown eyes. Next question. How many people have green eyes? Well, we don't know. But let's read the question. And the initial question said, let's just try and get this question, 30 children were asked. So we know the total number of kids that we've actually asked are 30. So if there's a total of 30, all these have to add up to 30. Now let's have a look at that. So I've got 12 and 2, which is going to give me 14, and 9, which is going to give me 23, as well as another 4, which is 27. So I've got 3 kids that are going to give me green eyes, or we're going to have green eyes anyway. Okay, let's double check ourselves quickly. So on our calculator, we're going to say, all right, So we are saying we've got a total of 30. We're going to subtract the 2, subtract the 12, subtract the 9, subtract the 4, and we'll end up with 3. And our answer is absolutely correct. Okay, and so I've double-checked myself just to make sure I haven't made a silly, stupid, careless mistake, because that can happen, hey? Mistakes are so easy to make. Ask my dad. All right, now, next question. I think next question. Yeah, here it is. Now, the graph shows the temperature of a substance over a period of 5 hours. What is the range of the temperatures shown? A very basic little question to do with range. But instead of giving you the highest number and lowest number and saying calculate the range, and we say, well, range is highest minus lowest, slap in the figures, get the answer. What we've done in this question is we've given you a highest and a lowest mark or temperature, but in the form of a line graph. So now, not only are we just testing, do you know what range is, but we're also saying, can you read a graph? So let's have a look at this. So what is my highest temperature? I would say my highest temperature is this guy over here. Well, how high is that? Let's try and find out. Let's go green line. Let's draw a green line. From here, and we're going to go all the way across, and it stops round about over there, which is just above 50. My lowest is round about over here, which is close to 40 degrees. So what is my range? Well, my range, I know, is going to be the highest minus my lowest mark. What's my highest mark? We said round about 52 degrees. What's my lowest mark? 40 degrees. What's my range? 12 degrees. So that's the range of temperature. Now, the other day I was teaching a group of guys, and they turned around and said, hold on, sir, let's have a look at something. And it was similar to this kind of question, not quite the exact same thing. But the gist of the question was this. If we were to draw a line, let's say someone said, you know what, I've got 51, and someone says, you know what, I've got 52, and someone else says, you know what, when I drew a line, mine went a little bit crooked, I got like 53. You know, I'd like to believe that the person marking your paper is going to give you a little bit of a leeway. He's going to say, you know what, I want 52. But I'll accept 53 or 51 because you know what? I still know that this student knows what he's talking about. So I'm going to give a little bit of leeway in my answer. Same way here, right? I got an answer of 40 degrees. What happens if I got 39 or 41? Well, again, I'd like to believe that the person marking your paper is saying, you know what? Let's give it a little bit of a leeway. Unless, of course, they've drawn all these horizontal lines and it shows that it's exactly on 40 and it shows that it's exactly on 52. Then you've got to be 100% accurate, because then they're actually testing, can you read these graphs accurately? Here what we're doing is, do you understand range, and can you work out that that's your highest and this over here is your lowest? All right, understand? Great, let's move on. My next question says this. In a game show, a contestant must throw 3 dice simultaneously. Means at the same time. In order to win 10,000 Rand, the contestants must throw an odd number, a number less than 3, and a multiple of 5. What's the probability that the contestant will win 10,000 Rand? Sure. So, what are we actually saying? We're saying this. To win 10,000 Rand, you've got to throw a dice, 3 dice. Throw them at the same time. Okay, so you take the dice, throw them, and voila, you see the result. In order to win, okay, one of the dice has to be what? Throw an odd number. Now, how many possible outcomes are there on a dice? There are 6 outcomes. How many are odd? 3 numbers are odd. A number less than 3. So he's got to throw that, and he's got to throw a number less than 3. So there are 6 possibilities. A number less than 3 can only be 1 and 2. It can't be 3, eh? It can only be 1 or 2. So there are 2 possibilities. And a multiple of 5. Now, my third dice, how many multiples of 5 are there? There's only one multiple of 5, right? And that's 5. So it's one possibility. Now, when we multiply all that out, we're going to say 3 times 2 is 6, times 1 is 6. 6 times 6 is 36, times 6 is going to be 216. But we are hoping it's going to simplify itself down. So let's do that quickly on our calculator. We're going to say, right, we've got fraction button 3 over 6, and we're going to multiply it by fraction button 2 over 6, and we're going to multiply it by fraction button 1 over 6. And what is our answer? 1 over 36. So how did I get 6 over 16? Well, I multiplied the top line and the bottom line, but what I did not do is I did not simplify it. And that's the beauty of using your calculator, is that your calculator takes your sum, takes your problem, and it simplifies it for you. So it's going to say, you know what? The chances are 1 over 36. Let's just get a pen here. There we go. 1 over 36. Sure, that's quite interesting, isn't it? I think it's nearly time to take a break, eh?
Let's do so. I know you learners remember that the questions are posted on our Facebook page. So while Peter's going on with it, you have it right in front of you. Just in case you miss a word or something, you know that you can also do it before he gets to the actual answer, so that you can check yourself and so that you have time to ask us what you're not understanding. So you can do that during the break. See you after the break. Welcome back, Mindsetters. I know that was a really quick break, but you guys don't even need breaks anymore. I know that, because now you're doing all your answers to Peter's questions, and you guys also know your stuff, so it goes really quickly. I know you guys are also enjoying the show, so it's awesome. Remember that there's also a boot camp, a winter school that will be starting on the 9th, right? Yes, 9th. And then you guys can tune in then. And that's when you can ask all the questions that have been bugging you over the past few weeks or few months of this year. It's going to be awesome, I think, Peter.
I think it's going to be absolutely great. Okay.
I like boot camps.
Guys, before the break, we were looking at a probability question, and I just want to clear up one thing very quickly with you, because otherwise it could lead to a bit of confusion, okay? For mathematical literacy, okay, we would never get this question unless we presumed that the first dice thrown had to be an odd number, the second dice had to be a number less than 3, and the third number had to be a multiple of 5, right? So that's how a question would be worded to you in a final paper. It wouldn't be they could be, anyone could be a multiple of 3 and any dice could be, because then we're going to land up with a whole bunch of permutations, which could be scary. And I don't even want to look into that because it's going to confuse you completely and utterly. All right, so I just wanted to clear up, we, with this question, are presuming that the first dice thrown was an odd number, the second one less than 3, and the third one a multiple of 5. Right, now let's move on to our next question. Our next question is quite an important one, and I just want to spend a bit of time on this question because it can be quite difficult to understand and difficult to grasp. Let's have a look at it. Iona, Lisa, Lauren, and Dom are on a road trip across around the country. They are approaching a railway crossing, and Lisa's driving. The lights on the warning sign start flashing, which means that a train is approaching. Lisa's traveling at a speed of 90 kilometers per hour. Convert the speed into meters per second. Okay. Now, nearly every single year that I know of, we've had a question which has come up where you've had to convert kilometers per hour to meters per second, or meters per minute, or kilometers per hour convert to meters per hour. Okay, so we've got to know how to do these conversions. And guys, the most important thing to ask yourself when you are doing these conversions is this: what is my number going to get bigger or smaller? Okay, what effect is the question having on my number? Is my number going to get big, or is it going to get tiny? Okay, So let's have a look. So 90 kilometers per hour. I'm going to break this up into two parts. I've got 90 kilometers over 1 hour. So I'm breaking it up as though they're two entirely different questions. I'm dealing with 90 kilometers, and let's finish with 90 kilometers. Then I'm dealing with 1 hour, and let's finish with 1 hour, and then bring the two together again. So 90 kilometers, we want to change it into meters. Now, how many meters in a kilometer? There are 1,000 meters in a kilometer. So how do I get kilometers into meters? I'm going to multiply by 1,000. And I think that's pretty obvious, okay? A meter is about this long. So if I have a meter, which is going to be bigger, 1 meter or a kilometer? How far is a kilometer? Well, a kilometer is from here to 1,000 of those meters away, okay? Very far. So if I've got 90 kilometers, I'm going to have a lot more little meters. So I'm going to multiply this 90 kilometers by 1,000. And I'm going to land up now with 90,000 kilometers. Sorry, 90,000 meters. Okay. So something's in the water I'm drinking here.
Yeah, I think so.
Right, now, 1 hour, we want to change an hour to a second. How do I change my time into seconds? I'm going to say, right, I've got an hour. So if I've got an hour, how many minutes am I going to have? I'm going to multiply it by 60 to get the number of minutes, because there's 60 minutes in an hour. And then I'm going to multiply it by 60 yet again. Why? Because I've now got 60 seconds in a minute. So we're going to multiply it by 60 again. So I'm now landing up with 3,600 seconds. So far, what have I got? I've got 90,000 meters in 3,600 seconds. And that's the same thing as saying 90 kilometers in an hour. 90,000 meters in 3,600 seconds. But I want to know, how far am I going to go in 1 second? Now, how do I get this to 1 second? I'm going to take my 3,600 and divide it by 3,600 to get 1 second. And what I do to my one side, I'm going to do to the other side. So I'm going to divide this as well by 3,600. So let's do that on my calculator, because my brain could never, ever, ever do such a complicated thing. So we're going to say 3,600. No, we're not. We're going to say 90,000. 1, 2, 3, there it is. Divided by 3,600. And we're going to land up with an answer of 25. So I've got 25, if I get a pen, 25 meters in 1 second. In other words, 25 meters per second. Sure. Now, guys, if we do that in an exam or a test, you can't go wrong. So I've got 90 kilometers per hour. Let's break up that 90 kilometers. Let's break up the hour, deal with the kilometers, deal with the hour, and when we finish dealing with them, bring them back together. So what we did was 90 kilometers, 1 hour, pretend the 1 hour is not there at all, and let's deal with the 90 kilometers. 90 kilometers times 1,000 gave me 90,000 meters. That's a 0 over there, okay? Then we said, right, so we've got it in meters. Now let's deal with our hours and change it to seconds. 1 hour times 60 minutes times 60 seconds is 3,600 seconds. Now we've got 90,000 meters in 3,600 seconds. We don't want to know how far we're going in 3,600 seconds. We want to know how far we're going in 1 second. So we're going to divide it by 1. We divide the 3,600 by 3,600 to get it to 1. We do the same this side, 90,000 divided by 3,600, and we get 25. In other words, 25 meters in 1 second, or 25 meters per second. Sure. Those are difficult concepts to understand. But guys, we've got to be able to do that. I'm going to digress from my question a bit, and I'm going to give you another one that we're going to work through very quickly. So let's do that. Let's say I give you a question where I'm going to tell you, you know what, we are traveling, let's say I'm going to run, and I'm going to run really, really, really fast. So I've got 100 meters to run. And in 100 meters, okay, I am going to do 100 meters, and let's say I'm a really, really, really good athlete, okay, and I do it in 10 seconds. Now, I could just imagine everyone looking at me and laughing at this. Don't get ugly,
no, I'm
man.
joking.
Jeez, that's horrible. Okay, so I've got 100 meters, and I'm running it really fast and doing it in 10 seconds, okay? Why? Because I just saw my mother-in-law approach, so I'm bolting for it. Okay, so 100 meters in 10 seconds. In other words, I'm running per second. How do I get this to be 1? I divide by 10, so I'm dividing this by 10. And I've got 10 meters per second. Are we in agreement with that? Okay. Now, so if I'm running at one heck of a pace, 10 meters per second, and someone says, hey, what's the speed in kilometers per hour? Wait, there's an interesting one, hey? How fast are you running in kilometers per hour? That's not something people work out every day, okay? True. But it's very interesting. So how fast is someone actually running in a speed we can understand in our mind? Because a lot of us know how fast 60 kilometers an hour are, or how slow 20 kilometers an hour are, or how fast 120 kilometers an hour is, okay? We know that. But if I say 10 meters per second, we're thinking, well, is that fast? Is that slow? What is that? Let's have a look. Let's change it to kilometers an hour. So I've got my 10 meters. How do I change that to kilometers? Well, 10 meters in kilometers, we're going to divide by 1,000. So when I say 10 divided by 1,000, and our calculator does that beautifully for us, we say 10 divided by 1,000, there she is, I get an answer of 0,01. So my answer now of 0,01, what? Kilometers. Okay? Now, let's change our 10 seconds into hours. How do we change seconds into hours? Well, we've got to change seconds to minutes first. How do we do that? We divide it by 60, don't we? Okay? No, in fact, we're going to times it by 60. Why times by 60? Well, if I run so far in a second, I'm going to be able to run a lot faster in a minute. A lot further in a minute, aren't I? Absolutely. Okay? So I'm expecting to go further and further and further in a minute. But for this problem, what we're actually saying is let's take seconds, change it to minutes, and then change it to hours. Okay? So what I am going to do is I am going to say, right, 10 seconds, let's divide it by 60 to get it into minutes. So how far am I actually running in minutes? Then in hours. So let's do that. So we are now going to say, right, I have 10, okay, divided by 60, divided by 60 again, equals, and I get an answer of, oh, a long answer. Let's just go back to 1 over 360. Okay, oops, let's get rid of that quickly. We'll go there. Cool. So we get 1 over 360. Okay, so that's how far we're running in hours. Now what I want to do is I want to say, well, I want to work out how far am I going in an hour, not 1 over 360th of an hour. So let's change this to 1. How do I get 1 over 360 to 1? I'm going to multiply it by 360. Let's just check if we are talking the truth here. Okay, so times that by 360, and voila, my answer is 1. So I now got 1 hour. What I did to my one side, I'm doing to this side. So we're going to say, well, let's also multiply this by 360. So out comes our calculator, and we're going to say, right, we've got 0,01 multiplied by 360 equals 3,6. So we're going to write 3,6. What does that mean? It means I'm running 306 kilometers per hour. Okay. Sure. That's quite a lot of work, eh?
That is.
All right. But do you understand? If we just break it up individually and then bring it all together again, things are going to actually work out. All right. Let's move on to our next question. If we can. Yes, we can. Right. Still to do with the train. So Iona, Lisa, Lauren, and Dom are on a road trip around the country. They are approaching a railway crossing, and Lisa's driving. The lights on the warning sign start flashing, which means that a train is approaching. She slams on the brakes while the car is still 70 meters from the train tracks. Using the following equation, calculate how far away from the tracks they stopped. Now we're using speed in meters per second. And if you remember from our previous question, we worked out that speed and we said the speed was 25 meters per second. So we're going to apply it to this question. So what we're saying is, okay, so she's going to, her speed is 25 meters per second, and we're going to square that. Why? Because some reason the formula tells us to. And we're going to divide it by 12. Why? Because again, for some reason, the formula tells us to. And when the formula tells me to do something, I just do it. A formula is like my wife. Okay? They say, hey, do this, you do it. You do not question a woman. Okay? You do not question your wife. And you don't question a formula either. It says do that, you do it. So it says, take your speed, square it, yes sir, or yes ma'am. Divide it by 12, yes ma'am. Why? I have no idea, but I'm just going to do it anyway. Right, so here we go, and we're going to say out on our calculator, and we've got 25, we're squaring it. We're going to divide it by 12 equals, and my answer is going to be 52,08. Okay, so 52,08. 8 meters. Now that's my stopping distance. So take note of that. That's how long it's taking me to stop. How far from the tracks have I stopped? That's my question. Well, if I started slamming brakes 70 meters away, and it takes me 52,08 meters to actually stop, then I can say, well, if I was 70 meters away, and I'm braking, and it takes me 52 meters, I'm just going to round it to 52, equals, I'm going to be 18 meters away from the actual track itself. Do you understand that? Okay, let's go through that again. So I'm driving along, or rather Lisa's driving along. She's going 25 meters per second. She suddenly sees the train, the light comes on, she says, I've got to stop, if not, I'm continuing the rest of this journey by train, but in that direction instead of there, which could be catastrophic. So let me slam brakes. So she slams brakes, she's 70 meters away from this train, slams brakes, and takes her 52 meters to stop. How close is she to the train? Well, if she started at 70, she skidded for 52 meters, she's 18 meters away from the train. Simple? Of course it is. Let's go on. The train is a long one. They see this, and to keep themselves occupied, they decide to work out the speed of the train. Their first step is to count the carriages. They get the following answers. Iona says there's 124 carriages. Lisa says there's 128. Lauren says there's 120, and Dom says there's 128. Okay, so they eventually stop, and now they see this train, vroom, 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 and all the coaches are coming past. And they say, hey, let's count how many carriages there are. And so that's what they do. Okay, they go 1, 2, 3, 4, 5, 6, 7. Eventually, Lisa says, or Iona says, 124. Lisa says, no, you're wrong, 128. Lauren says, oh, rubbish, they're 120. And Dom says, no, I think there are 128. I also got 128. Okay? So what's the mean average? Now, you know how to calculate means. Straightforward. Nothing tough about this. I know it's not going to be tough because this is a paper one. So I know that if I've got 128 plus 20 plus 128, and I forgot the first 124. Careless mistake here. Divide that now by the 4 people. So my calculator is going to do this for me. So I'm going to say, right, we got 124. We're going to add 128. We're going to add 120. 120, let's try that again. 120 plus another 128. And I'm going to get a total of 400. Divide that now by 4, and I'm getting 125 carriages. So there are 125 carriages on average, according to my 4 ladies who are busy counting this train. My next question says this: find the median average. Now, you know how to find the median. The median means we put all our data in order, and we find the middle one. Okay? So let's do that. All right. So I've got 120, 124, 128, 128. What's my median? It's going to be slap center in the middle. How do I find the median now? With 2 numbers, I'm going to add them and find the average. So my average, 124 plus 128 divided by 2 is going to give me 126. Finally, what's my mode? The one that occurs the most is 128. But we're not finished with this question yet, but we've got to take a break.
Let's do that. And I know by the way things are going on the page, yes, like you guys are going to ace these exams. Like, this is awesome, Peter. I wish you'd see this. Everyone's answering the questions really, really well.
Well, maybe after the break we can answer any questions that folk might have. So if you've got a question, post it up now while the ad's on, and once I've finished this, we'll answer
them, yes. And especially you guys with the exam tomorrow. Make sure that you're clear on everything. See you after the break. Welcome back, Mindsetters. I hope in this break you guys have already started typing all the questions that you may have so that you can send them through right this instance, because there is short time left, so we'll be answering very few questions if you guys have any. And make sure that they're concise and clear. Like, I know that you guys are understanding a lot, so you probably won't even need to, but hey, just make sure.
Cool. And we don't have very much time left. So let me get through this.
Okay, sure.
And once I've done this, I'll ask if there are any questions posted, and we'll try and tackle those. Yes. Okay. So let's go through this. So they estimate now that each carriage is approximately 12 meters long, and that the 2 locomotives, one at the front and one at the back, are 25 meters long. How long is the train in total if they agree that there are 128 carriages? So do you remember they've counted the carriages? These girls managed to stop in time before the train took them out, and they counted all these carriages, and someone said, hey, there's 124, 128, 120, 128, and so now they agree, hold on, okay, we'll make it 128. Why did they do that? Why didn't they take the mean instead? Do you remember before this, we had to calculate the mean, the median, and the mode? And the mean was 125, the median was 126, and the mode was 128. They've probably taken the mode because they've said, you know what, if 2 people got 128, chances are it's 128. Okay, they've ignored this guy here with 120 and saying, oh, you've just lost totally, you didn't know how to count at all. 124 is still pretty close to 128, and 2 people got 128, so we'll just pretend they're 128. So what they say is this, right, okay, so if we got 128 carriages, and each one is right about 12 meters long, and then there's a locomotive, you know what a locomotive, eh? That's that heavy machine, and right in front with electricity powers on top, and it pulls the train. And we've got a locomotive in the front, and we've got a locomotive at the back. Now, how long is my train? Well, this is going to be a simple little addition sum, so let's go for it. We're going to say, okay, so we've got, each carriage is 12 meters long, and there are 128 of them. Plus, we've got 2 locomotives, and each one is 25 meters long. How long is this train going to be? And our calculator is going to do that work for us. We don't even have to do it. We are going to say, right, I've got 12 times 128, and that gives me 1,536 meters, 1,536 meters. Plus, guys, I don't need a calculator for this, hey? 2 times 25 is 50 meters. Now we're going to add it up and we're going to get 1,586 meters. Okay, even though I say you don't really need a calculator, you know what, I always tell my class, rather use it.
Make sure.
You never know if you've made a mistake. Okay, so there it is, 1,586 meters long. The next question, I know what it is, says convert this to kilometers. Now, how many meters in a kilometer? There are 1,000 meters in a kilometer, so let's divide this by 1,000. And we're going to get an answer of 1,586 kilometers in length. Sure, that is such a long train. Time's running out. Do you have any questions there?
No, there actually aren't any questions. Do you want to just recap on what you were doing now?
Okay, well, let's just keep going with this train question then, shall we? Okay. Now, convert the time into hours. Write your answer as a decimal. Convert what time? Let's have a look. Lauren was timing how long it took the train to pass in front of them. That's how her total was so different from the rest. Okay, remember Lauren only got 120 coaches, but that's because she wasn't really focused on counting. She was just timing the train. And she says, hey, you know what? That train took 7 minutes and 30 seconds to cross in front of them. So 7 minutes, 30 seconds, which is what? 7.5 minutes. Okay? Now, convert the time into hours. So we've got 7.5 minutes. Let's convert it into hours. How many minutes in an hour? There are 60. So I'm going to divide this by 60. And let's see what our calculator gives us. It's going to say, right, we've got 7.5. We're going to divide it by 60. And we're going to land up with an answer of 0.125. So I've got an answer of 0.125 hours. Okay. What's my next question? My next question is, use your answers from question 5.34 and 5.41 to calculate the approximate speed of the train in kilometers per hour. Now, do we remember how long this train was in kilometers? Kat, can you remember? It was 1,536
I don't remember.
kilometers. Hey? Something like that. Should we double check ourselves?
Let's just double
do that,
check.
hey, because it's always good to double check yourself.
It always.
All right, let's see that. It was, in fact, we did it over here. It was 1,586. Ah, it's a good thing we did that. We would have got the wrong answer. So 1,586. Sure,
almost, you're almost right.
8. How perfect is
Yes.
that? All right, now we're going to divide that by my time. What's my time? 0.125 hours. So now we're going to get an answer in kilometers per hour. So with our calculator, 1,586 divided by 0.125 equals, and here's my answer, 12,688. So my train is going 12,86, or what? 886, was it? 688. Oh my goodness, my brain is just not working today. 12,688 kilometers per hour. Okay, that train is going so slowly. I think it's pulling a big load behind it, which is really...
Yeah, that's why trains always take long to travel with.
Absolutely. Hey? Okay. Okay, we've got less than a minute again, and once again, time has just absolutely flown by. It's amazing how that happens. Viewers out there, you guys are about to write your exam. If you haven't written it already, everything of the best. Throughout this whole series, we've given you a bit of hints. We've tried to help you out. We've given you a few ideas on how to tackle questions and answer questions. I trust it's going to help you. And please remember, if you don't do well in this exam, tune into boot camp, and it'll really help you later on.
Yes, it will. Thank you very much, Peter. Thank you, Mindsetters. It was an awesome show, and remember, we will be seeing you during the boot camp. And, of course, grade 12s are up next. See you next week.